The fundamental theorem of arithmetic. The fundamental theorem of arithmetic is a very useful method to understand the prime factorization of any number. This theorem is also called the unique factorization theorem. The basic idea is that every positive integer greater than 1 is either a prime number, or can be written as unique product of prime numbers. Any integer greater than 1 means the numbers 2, 3, 4, 5, 6, etc. A prime number is a number that cannot be exactly divided by any other number, except the number 1. The first few prime numbers are 2, 3, 5, 7, 11, 13, 17, and so on. Product of prime numbers means multiply prime numbers together. If we multiply some or all of these numbers, allowing them to repeat as many times as we wish, we can produce a large collection of positive integers. Here are some examples. In other words, all the natural numbers can be expressed in the form of the product of its prime factors. Now, let us suppose your collection of primes includes all the possible primes. What is your guess about the size of this collection? Does it contain only a finite number of integers, or infinitely many? In fact, there are infinitely many primes. So, if we combine all these primes in all possible ways, we will get an infinite collection of numbers. We are going to use the factor tree with which you are all familiar. So we have factorized as a product of primes, as a product of powers of primes. We can say that every composite number can be written as the product of powers of primes. In fact, this statement is true, and is called the fundamental theorem of arithmetic. The prime factorization of a natural number is unique, except for the order of its factors. In general, given a composite number x, we factorize it as x is equals to p1, p2, till pn, where p1, p2, till pn are primes and written in ascending order. If we combine the same primes, we will get powers of primes. Let us look at some examples. Find the LCM and HCF of 6 and 20 by the prime factorization method. We have
6 is equals to 2 to the 1 power, into 3 to the 1 power. And 20 is equals to 2, into 2, into 5, which is equals to 2 to the 2nd power, into 5 to the 1 power.
You can find Note that HCF 6, 20, is equals to 2 to the 1 power. Product of the smallest power of each common prime factor in the numbers. LCM, 6, 20, is equals to 2 to the 2nd power, into 3 to the 1 power, into 5 to the 1 power. Product of the greatest power of each prime factor, involved in the numbers. Find the HCF and LCM of 6, 72 and 120, using the prime factorization method. We have here, 2 to the 1 power, and 3 to the 1 power are the smallest powers of the common factors 2 and 3, respectively. So, 2 to the 3rd power, 3 to the 2nd power and 5 to the 1 power are the greatest powers of the prime factors 2, 3 and 5 respectively involved in the three numbers. So, notice, 6 into 72 into 120 is not equals to HCF of 6, 72, and 120 multiply, LCM of 6, 72, and 120. So, the product of three numbers is not equal to the product of their HCF and LCM. In the next video we will learn about irrational numbers. Till then, Take care and don't forget to like, share, and subscribe our channel. Thank you.